A large portion of automotive service includes using scan tools in scanning different modules and reading the data that's within those modules. For all the different systems involved on a vehicle, there's likely a module present for each system on the vehicle. Using these modules and the data help us determine the best plan and course of action to take on a certain circuit. It also can clue us into a mechanical fault depending on what the data is showing. We'll be using two scan tools today. One is a more generic scan tool code reader, one like this. That's great for checking codes, reading codes, and clearing codes, sometimes, and reading for monitor data for emissions. Sometimes it gives pretty key information. Most of the times it's pretty limited, and the price reflects that. It's about an $80 unit compared to the Modus scan tool like this. This platform is now outdated, but the program is still the same and testing is still the same. So I'll be able to go over a few things with this because it is more versatile, and when this was new it was substantially more. It was a few $1,000s for this unit, and with the subscription for Snap-on support it ends up being about $9,000 to $10,000 for this unit new. Not the case anymore. It's worth maybe a few $100s with all the updates that it has up through 2017. It's valuable up to a point, but there are better ones available now. This is what I have to go over scan tool operations with, so that's what we're going to use today. Located underneath the dash, within close proximity to the steering column, will be the data link connector. The data link connector for OBD2 vehicles is a 16-pin connector, and it may not use all 16 of those pins. You can see in this one, there are only 4 pins being used. I'm going to hook up the code reader to it. I'll just walk through some of these menus and show some of the data that this shows. And if we want to, we can reset the oil lamp if this vehicle requires that, look up diagnostic trouble codes, search for OBD2 help, tool setup, and tool information. We can input a code number. For instance, P0300 is the code for multiple cylinder misfire or random cylinder misfire. It's a generic code, random/multiple cylinder misfire detected. This would help if you had a code number but didn't know the definition. You could look it up. If we go to OBD2 diagnose, right now it's detecting all control units and it's providing information. Currently the MIL status, or the malfunction indicator lamp status, is off, which is true. There are no stored codes, there are no concerns at this time. We'll select View All Items. And we can read through some of this data information, but it's very slow to process and it's very limited. We also don't have bidirectional controls. Take a look at that fuel rail pressure. That's a diesel for you right there. About 29,000, 30,000 kilopascals. We can look at emissions information. This is a diesel, so it doesn't support a lot of these readiness monitors, but we can look at readiness monitors in case needed for enabling a vehicle to get tested through DEQ. So a lot of these are just not applicable. These are normal readiness monitors that a gasoline system would be monitoring. Now let's compare it to what information is available through the Modus scan tool. So I will apologize right off the bat about the quality here. So at the beginning we have the vehicle communication, and we can select previous vehicles, US domestic, Asian, European, global OBD2, scanner demo, heavy duty truck. We can go back and scroll down to component testing, put in a vehicle ID, and then do guided component tests if we're looking for certain testing on a connector or a sensor, some other component of the system, depending on the system. That would give us a guide as to how to test that. There's also a digital and graphic multimeter function where we can compare a waveform, an actual waveform, against a signature waveform, and it'll display on the screen here. There's a lab scope function. We can do the ignition scope. There is a 5-gas analyzer, save data, and utilities to set up the tool. Under save data, our previously saved files for different vehicles. So waveforms can be saved and data can be saved and then shown to the customer after the repair is done and show the before and after, or it could be saved to compare for the technician at a later time. We'll go into previous vehicles, select the 2005 GMC Sierra. Right at the top of the list. And once we get into the main menu, we can select the different systems on the vehicle. We can go into engine management system, transmission control, anti-lock brakes. One of the cool things about working with the scan tool is that you may have the ability to do bidirectional controls. Now, bidirectional controls can be a very key component in testing when you are trying to rule out whether or not a switch or a component isn't providing information as an input, so you can directly output a control without receiving an input to the control module. So if we go to output controls, and for instance, we go to, you can disable injectors, mill on and off. So by selecting back and forth, we can turn the mill on and turn the mill off, or the check engine light. So take a look up here. So I'm selecting mill on, and then the mill off. So I can illuminate and turn off the check engine light through the output controls. I'm doing that with the scan tool through the engine control module without there actually being a code present in order for the control module to turn on and illuminate the light. This is an example of one of many output controls you can do while you're testing to see if something is working or receiving its output command from the control module. This can rule out certain circuits through the testing process, and it can all be done from the driver's seat. For the sake of this class, let's go into the anti-lock brakes system. Let's go to data display, ABS data. Now if you look at these three lines here, left front wheel speed, right front wheel speed, rear wheel speed. So this looks like a 3-channel ABS system. And no, we're not going 3 miles an hour, I'm stopped. And if we go up here to view, up in the corner, and I select foregraph, this will break up the data and show it in a foregraph layout. Now what I can do is scroll down, and now I'm watching left front wheel speed, right front wheel speed, rear wheel speed. So up at the top there's a pause button. It's tracking what's going on. So we have left front wheel speed, right front wheel speed, rear wheel speed. If we were suspecting a concern happening at a certain point and a certain speed in the system, we can record during a test drive without having to look at the screen or potentially get in a dangerous driving condition because we're distracted. We can let the scan tool record the event if it happens or occurs, and then if we feel it or know that it happened, then we can pull over and refer back to the data, pause it, and then scroll back through the process. So I'll take it on a test drive right now while recording that data. When test driving a vehicle, it's best to know when the concern is present, and it's difficult to duplicate a concern if it's intermittent, meaning it doesn't happen consistently or can't be duplicated reliably. For some of these situations, it's better to have the customer ride along with the tech and point out the characteristic or the concern when it's happening, rather than the tech guessing whether or not the condition is occurring or not. This can avoid needless time and money spent by the technician and the customer. So they're not chasing something that's not happening, and as long as the technician's working, they're getting paid. So it has to be established pretty early on whether or not the condition it can be duplicated. If it's intermittent and happens during a test drive, then that's when the technician might do an example of what we're doing right now. Let's say, for example, there was the ABS warning light comes on and there's a code pertaining to one of the speed sensors. Depending on what that might involve, the data that we're trying to find may involve driving the vehicle at a certain speed for a certain amount of time, and then reviewing through the data to see if that wheel speed sensor is putting out a clean signal, or in this case, if it matches the other sensors. So what we're monitoring right now is wheel speed sensors to the front, the left front and the right front wheel speed sensors, and the one common channel to the rear. So this is a 3-channel system, and we're monitoring the wheel speed sensors. As we're driving, it's normal driving conditions, and the test drive should reflect what the customer says is the conditions for the concern to be active. While we're doing that, the radio is off, the creature comforts are off, we're not hot rodding, being diligent members of society while we test and try to resolve the issue of what's happening in the system. So if the concern happens at highway speeds, the vehicle needs to be driven at highway speeds. If the concern happens in stop and go traffic, then driving through a residential neighborhood with a lot of stop signs may be the test drive that's better. Depending on what the situation is, will determine how the test drive is supposed to be duplicated, and will ultimately shorten the amount of time that the technician needs to put into duplicating the problem and finding the solution, or finding the cause. Once the information can be recorded and reviewed, then the technician can go through the information and make an educated decision as to what should be the next step. Always be respectful with somebody else's vehicle. Depending on the concern, it may be present at a speed that isn't legally attainable within the scope of the test drive. This would likely involve a conversation with the customer about not being able to duplicate certain things at certain speeds if, for example, they had a vibration at 85 miles an hour. Well, it's not responsible to take a customer's vehicle and risk getting a speeding ticket and potentially other tickets for unsafe driving of a vehicle for the technician. Most shops won't bail out their own technicians, and it goes on your driving record. Not all police are going to be understanding that you're working on the clock and trying to resolve a customer issue if they pull you over for speeding in a customer vehicle. Depending on the severity of the infraction, sometimes getting pulled over by police involves having the car towed away. So you can see where I'm going with the concern of driving a vehicle out of the scope of the law and potentially test driving a customer's car, and it ends up getting towed and you end up getting a ticket and you got a fine to pay and you got a court date and it's on your record and your insurance level goes up. That brings up another point. If you have something come up on your driving record that affects your insurance, most of the time that information is going to be relayed to whatever shop or dealership you work at for their insurance covering you as an employee. keeping a clean driving record is very important in this industry. It enables you to be hired. A lot of the times, if you have infractions on your driving record, insurance companies that shops are insured by, upon review of the DMV record that is submitted to them with your approval, they'll state whether or not you're insurable. If not, you can't be hired. I'm sorry, there's no reasonable position for a technician who's not legally able to drive. I've seen shops try to accommodate certain technicians by having the apprentice do the test driving, by having another technician do the test driving, and it just ends up being a big burden for everybody. So keep your record clean. Be responsible. Don't get excited driving somebody's fancy car because it's exotic or fun. Pull into a nice shady parking lot here. Alright, so here we are after driving the vehicle. We're looking at the top 3 graphs. I'm going to pause it. Then I'm going to select review, where I can go back to the beginning of the test drive, and it looks like all speed sensors read a minimum of 3 miles an hour and maximum of 39 miles an hour. And we can scroll through the data and make sure that they all line up. So you can see when the vehicle was stopped. This is rear, this is right front, this is left front. And comparing them all together, they're all doing the same thing. And that's what you want to see. If we had one of these that was dropping out or was reading a flatter curve than the other ones, we would suspect that there's an issue with that circuit or that sensor. Showing 3 miles an hour as the minimum rather than 0 likely means that this truck has AC generator style wheel speed sensors and vehicle speed sensor. As we saw in the graph on the picoscope, it wasn't easy to tell much of a waveform at low speeds, so they aren't very reliable below 5 miles an hour. So that's likely why this shows a minimum of 3 miles an hour, even though we've been stopped multiple times and 0 should be the correct number. But based off of the technology that they used on the wheel speed sensors, it's good enough above 3 miles an hour for this vehicle. Being a truck, it doesn't need to be that sensitive. Scan tools are very useful when it comes to testing and monitoring certain systems in the vehicle. Once you have exposure to it and keep using it, you'll become more familiar with it. And using different types will help you understand the differences between different scan tools and what you prefer about certain ones versus others, how certain ones work with certain types of vehicles, when to use a manufacturer's scan tool, when to use a code reader. So myself, coming from an independent shop background, I have experience using the Modus platform, and it works pretty well for everything, for the most part. And then for some of the European stuff, we used the Autel scan tool. And by using the Autel scan tool, it has a completely different configuration, and it was a bit of a learning curve just to get used to using it. And it made a big difference once I was able and comfortable using the Autel on certain vehicles. And then I would use it as a backup. If I was not finding what I needed to in the Snap-on scan tool, then I would grab the Autel and see if there was something else that it was able to show me or communicate with the vehicle that the Modus wasn't able to. The aftermarket scan tools are decent for use on a wide range of vehicles and can do a lot of the same functions as a factory scan tool. For the price, it makes a lot more sense to use an aftermarket scan tool. The code reader is great for after doing a repair, verifying the repair, and making sure there aren't any pending codes left in the system after doing an initial test drive, confirming the repair. The code reader is quick to hook up and it shows you codes really easily. And if there's codes pertaining to the system that you just worked on, they'll show up on that tool, and then you can get the other scan tool out and get down into exactly why that code might be present. For quick checks, it works great. If a customer comes in and has a check engine light on, it's really nice to grab that little handheld unit and pop on out to the car and see if you can pull a code off of it and get a definition for a code. So they're useful in their own way, but you can do a lot more with an aftermarket scan tool or a factory scan tool. Some factory scan tools have the ability to program new software into a component that has an update available for it. As you use more scan tools, get used to the different functions in them. Do a little exploring with the scan tool and see what systems you can enter and which ones you can't enter and what you can and cannot do. There's a lot of information in there, and there's a lot of functions that you can utilize the scan tool for. And the nice thing is, you can do a lot of your diagnostics from the comfort of the driver's seat. It's a lot easier to do testing from here and then figure out what's working and what's not working, or what you can or cannot test with the use of the scan tool before you open the hood and before you start poking around and disconnecting things and removing components and disassembling and doing investigative research. Most technicians won't start disassembly until they know what they're looking for, and they know that disassembling a certain component is going to show what the cause of the problem is. Until that time, it's testing and reviewing data and working with the scan tool, looking at output controls, bidirectional controls, that sort of thing, and doing some research. Because once you start removing parts and exposing gasket surfaces, then you need to get parts coming, and that all needs to be sold to the customer. So you should be almost positive that certain things need to be removed before you go removing certain components. I hope this information was helpful with scan tools. Scan tools are something to get used to. Majority of the vehicles are going to be handled by using scan tools more and more in the future, and the vehicles that don't require scan tools are becoming much fewer on the road. So it's a good thing to know, it's a good thing to learn. So get comfortable with them, get comfortable with several different kinds, and really figure out how to use them, because they are a very useful tool to be able to flex your knowledge with and make diagnostic testing fast and efficient, and then it makes you a more reliable and valuable technician. So until the next one, thank you.